All right, looking at composition of functions is what we're doing here. Composition of functions is a really, really big, important topic. Composition of functions, in that we use it time and time again. Now, this is where you're basically plugging in one function into another and vice versa. F of g of x means this, which basically means that whatever g of x is equal to, that's getting plugged in as your x into the f function, the one outside. So looking at let's look at number 36, for instance. Okay, 36, which you are doing for your homework, says find f of g. It also says find g of f, and if possible, f of g of 0. So f of g of x here. F of x is the cube root of the quantity x minus 1. G of x is x cubed plus 1. So f of g of x, this means literally, I'm going to take this, and since g of x is x cubed plus 1, this is going to become x cubed plus 1. So in other words, I am plugging into the f function x cubed plus 1 anytime I see an x. So here's the f function. That means cube root. I see an x, so I'm going to plug in x cubed plus 1. Then I have a minus 1 that's already in there, so I'm going to do that, which gives me the cube root of x cubed, which is just x. So that's my answer for f of g of x. And then I get to go back and do it the opposite way and take, for g of f of x, I get to take whatever f of x is equal to, which is cube root of x minus 1, cube root of x minus 1, and plug that in place of x in the g function, the one on the outside. So in place of x means I'm going to do something cubed plus 1. And here's the something. So this cubed plus 1. Well, if you cube a cube root, it has the effect of basically just negating the cube root, taking it away. So this whole thing just boils down to x minus 1. And then I got a plus 1, and that equals x. Now, one of the things we're going to look at tomorrow involves why this one's special. Notice that when I did f of g of x, I got x. And when I did g of f of x, I also got x. Okay, so that goes into inverse functions, and that's something we're going to take a look at tomorrow. Notice that on 35 to 38, they don't ask you anything about the domain. In 39 to 43, though, that changes. So let's look at 40. Number 40 says I have f of x is the cube root, excuse me, not the cube root, the square root of x plus 3. And g of x is x over 2. So this is what we have. Determine the domains of f, g, and f of g. So first I'm going to look at this and say, I'm going to figure out the domain of this. Remember when you have a radical, the domain involves taking whatever's under the radical and saying that has to be not negative. So this means x has to be greater than or equal to negative 3. If we picture a number line, that means from negative 3 all the way up to positive infinity. So this is from negative 3 to positive infinity. That's the domain of f. Now the domain of g, this is just a linear expression. This is 1/2 x. So that's all real numbers. Okay, remember that denominators is something that we look at when we're looking for domain, but we don't care about denominator unless the denominator has an x in it, because the whole question is what would make the denominator equal to 0. Nothing is going to make a 2 suddenly change into a 0. It's only if there's an x in the denominator somewhere that we could possibly have a denominator turn into 0. All right, so I found the domain of f, the domain of g, and now I have to find f of g so that I can find the domain of f of g. So f of g looks like this, and we always rewrite it like this. Means I'm going to take whatever g is, it's x over 2, and plug it in as the x, or in place of x, in the f of x function. So f of x over 2 equals the square root of x over 2 plus 3. So looking for the domain of this means we have a radical. It means making sure what's underneath here is positive or 0. In other words, non-negative. So that plus 3 has to be greater than or equal to 0. So x over 2 has to be greater than or equal to negative 3. Multiply both sides by 2, and you have x is greater than or equal to negative 6. So here's negative 6 all the way up to positive infinity. And there you have it. Okay, let's look at, let's see. That goes all the way up to 48. That's what you're doing, is finding the domain of each one, and then the domain of the composite. Just looking ahead, remember that if you see a fraction, you don't want the denominator to be 0. If you see a radical, you don't want what's underneath it to be negative. If you see absolute value, what's the domain of an absolute value function? Well, think about what it looks like. And this picture does not go with this problem I'm just drawing here. So let me hide that. It keeps going to the left and right forever. Domain is all real numbers for an absolute value. All right, lastly, you could do everything in 49 to 54. Same idea. The whole using a graphing utility to graph f of g and g of f, that means go ahead and find out what f of g stands for. In other words, like here. We did f of g and said, oh, we get x. So that's like graphing y equals x. G of f, that's x. So that's like graphing y equals x. All right, and then you're looking at whether those two are equal and using the graph to help you see. If they have the same graph, then they're equal functions. And that's pretty much it. Let me just do one more for good measure. How about number 53? I'm going to find f of g, and I'm afraid the custodian's about to come in with a vacuum, so be aware if you hear scary noises. That's what it is. This is f of, now what's my g? In number 53, g of x is x to the 6th. So I'm plugging in x to the 6th in place of g of x, and that means it takes the place of x in the f function. So f of x to the 6th means I have x to the 6th raised to the 2/3 power. When you have an exponent inside and one outside like this, they multiply times each other. So this is 2/3 of 6, which means x to the 4th. Now let's do g of f. That means g of f of x. So I'm taking what f of x equals, which is x to the 2/3, and I'm plugging that in to the g function. The g function is x to the 6th, so it's going to be that to the 6th. Well, look what happens. 2/3 times 6, once again, is x to the 4th. And I'm supposed to find the domain of f of g. F of g is x to the 4th. That's going to be all real numbers. No, it's not. Hang on, I'm sorry. Yeah, it is. I was thinking of range for a second. Domain's definitely going to be all real numbers. The range is not going to be unrestrained. The range has some restraints on it, some constraints on it. But the domain's going to be all real numbers. Let's see. Use a graphing utility to graph this. So that's like y equals x to the 4th. To graph this, that's like y equals x to the 4th. Determine whether they're equal. Well, you can see that they're equal, but look at their graphs and you should see that they also look equal. And that's about it.